Basically, I'm going to do the demo on this sort of foil, copper foil, but it's a special formulation of copper, specifically used for shielding of interfering signals and electromagnetic RFI, EMI, and things like that. And we do use it intensively. It is 0.023 millimeter flat. The strip is about 20 millimeter. It has got like a glue at the bottom, so you can actually glue it like I have done over here, like make it into strips like I have done over there. I deposit it into the strips. I can peel off here and I can actually glue it to whatever sort of unit I want to shield the type of thing. Now that glue that's underneath is actually conductive glue, so if I remove this paper and I glue it on top of this, it will actually make electrical and physical contact with the copper below or material below. So it's very easy to apply, and it's a fully conductive from both sides. Okay, and it's very thin, very easy to sort of operate. Now basically I got my setup is I got the spectrum analyzer, okay, with a specialized probe which acts as a pickup probe, picking up the noise. I got over here 12 volt from a DC power supply going into a sort of little switch mode power supply, which steps down 12 volt in this case. Right now, of course, I can adjust over here down to 6 volt, and I'm feeding that voltage into my load. Okay, so that's a basic setup. Right now, as it is, this probe is approximately 1.5 centimeter away from the closer to the output of the actual unit. Now, because this thing operates at very high frequency, it generates a lot of noise. And you can see on the spectrum analyzer, which I'm analyzing, and I'm using span from 2.5 megahertz to 100 megahertz. You can see at 20 megahertz, I'm getting minus 73.5 dBm attenuation. Okay. And minus 70, I mean not attenuation, I'm getting the noise of minus 73 dBm. And minus 73 dBm, it's approximately about 50 something microvolt, which is quite a sort of substantial signal, which can cause a havoc. And of course, the bigger the load and bigger the voltage, or bigger the output voltage, the more noise it will generate. And it will bleed all over, interfere with FM, with instruments, with a lot of different electronic units. Nonetheless, I made a little strip here on a piece of paper, just wherever. Okay, I'm just going to use that copper, and I'm just going to put it over there. Okay, now watch what happens. Can you see how much it attenuated? It went from 77. Okay, wait. Let's get it going. Let me just put it properly. Okay, from 73 dBm, it basically went to 78.5. Okay, which is an increase of about it's 8 minus whatever. It's about 4 to 5 dB, somewhere around there, plus minus. Okay. Now 5 dB, it doesn't seem like very much, but 5 dB in a very layman's terms, it means about 6 times attenuation of the actual radiated signal. But realize one thing, this is not the ideal isolation, because the signal is still, the RFI and EMI is still coming, and the noise coming from the other sides and from the cable, getting radiated from the cables and so on. But nonetheless, it has done the attenuation, which proves that this 0.023 millimeter is attenuating. Now, I'm going to take a bit bigger piece, and I'm going to slide it over there, and watch what happens from 78.5 when I actually slide it. Okay, now watch it there. You can see substantial amount. Okay, it's gone to 88, whatever, 88, something dBm. Now 88 dBm, okay, down to 73, that is approximately about 15 dBm attenuation. Of course, the signal, it's not ideal condition because the signal is still seeping through there, through all these gaps and so on. But the more, if I put the extra sort of copper, it will attenuate again and things like that. But even if I make like a tubular and then I slide this thing and I shield it 100%, this power supply, the probe, it will definitely go up to anywhere up to 20 dBm attenuation. And 20 dBm attenuation or 20 decibel attenuation, it gives you more than 100 times of the actual attenuation of the interfering signal. So I'll just quickly demonstrate that. With a very quick sort of power supply, we generate lots of noise, fed into a spectrum analyzer, and just by putting the copper strip on top and another sort of, extra shield, you can definitely see that it attenuates it by something like anything up to 100 times. But if it's 100% sort of shielded, tapoa tin, and you make it like in maybe 1 or 2 layers or 3 layers tapoa tin of this isolation, you can achieve even greater attenuation, more than 150, 200 times tapoa tin, attenuating unwanted radiated signals. On that note, thank you for watching Batos or RFI EMI shielding sort of tape that we do use and sell here at the shop. Thank you.